If the universe is so vast, so ancient, and so rich with opportunities for life, then where is everybody? When you follow the physics to its conclusion, the answer is at once straightforward and deeply unsettling. The universe is simply too large. Not large in the familiar sense of oceans or continents, but large in a way that overwhelms every conceivable method of travel or communication. There are more stars within the observable universe than there are grains of sand scattered across every beach on Earth. That statement is not poetic exaggeration. It is the result of careful calculation. There are roughly 200 billion trillion stars, and each of them is a sun in its own right, many accompanied by planets circling in their gravitational embrace. The Kepler Space Telescope, looking at only a tiny region of the sky, identified more than 2,600 confirmed exoplanets on its own. When those findings are extended across the entire Milky Way, the estimates rise to somewhere between 100 and 400 billion planets within our galaxy alone. Some of these worlds lie within habitable zones, regions where liquid water could persist on the surface. Some have occupied those zones for billions of years, far longer than life has existed on Earth. Faced with numbers like these, it feels almost inevitable that we are not alone. It seems reasonable to imagine that somewhere other intelligent beings have emerged, constructed civilizations, gazed upward at their own stars, and asked the same question we do about whether anyone else is out there. And yet, we encounter only silence. No signals, no visitors, no trace at all of intelligence beyond this single planet. This absence is profound. It is the Great Silence, a puzzle that has troubled astronomers and physicists for decades. The separations between stars are so immense that, for all practical purposes, they may as well be infinite. And in a universe where nothing can travel faster than the speed of light, distance becomes time. Time that surpasses human lifetimes. Time that exceeds the duration of civilizations. Time that may even outlast entire species. The nearest star to our Sun, Proxima Centauri, is 4.24 light-years away. A light-year is the distance light travels in 1 year, roughly 9.46 trillion kilometers. That places Proxima Centauri at about 40 trillion kilometers from Earth. The fastest spacecraft ever built by humanity, the Parker Solar Probe, reaches a peak speed of about 700,000 kilometers per hour. Even moving that quickly, a journey to Proxima Centauri would take around 6,500 years. That is longer than all of recorded human history. By the time such a spacecraft arrived, the pyramids of Egypt would have been ancient ruins for millennia. And this star is the closest one. In cosmic terms, it is our immediate neighbor, almost touching us when compared with the scale of the galaxy. The Milky Way itself spans roughly 100,000 light-years. Its center lies about 26,000 light-years away from us. Stars on the opposite side are so distant that the light leaving them when the first dinosaurs walked on Earth is only reaching us now. Any signal we send, any spacecraft we launch, would require tens of thousands of years to cross even a small portion of our own galaxy. And the Milky Way is just one among hundreds of billions of galaxies. The nearest large galaxy, Andromeda, is 2.5 million light-years away. The observable universe stretches 46 billion light-years in every direction, containing structures of such immensity that the Milky Way itself is no more than a single grain of sand on an endless beach. So when we speak about meeting alien civilizations, we must confront what this scale truly implies. Even if intelligent life is common, even if thousands or millions of civilizations have arisen over cosmic history, the distances between them render contact effectively impossible. Picture two civilizations located on opposite sides of the Milky Way. A signal traveling at the speed of light would take 100,000 years to arrive. A reply would require another 100,000 years to return. One simple exchange would span 200,000 years, longer than modern humans have existed. Any real conversation would stretch across millions of years. By the time a response arrived, the originating civilization might be extinct, transformed beyond recognition, or have forgotten that it ever sent a message. This is not a limitation that clever engineering can solve. It is the nature of reality itself. The speed of light is not a barrier waiting to be broken. It is a fundamental feature of space-time. Nothing that carries information can exceed it. No signal, no spacecraft, no message of any kind can outrun this limit across interstellar space. And on the scale of the cosmos, light is slow. Humanity has been leaking radio signals into space for about 100 years, since the earliest days of radio communication. Those signals travel outward at the speed of light, forming an expanding sphere centered on Earth. After a century, that sphere has reached a radius of 100 light-years, enclosing perhaps 15,000 stars. In the language of the cosmos, this is essentially nothing at all. The Milky Way is home to hundreds of billions of stars. Our expanding radio bubble has so far reached only about 0.00001% of the galaxy. Even within that tiny fraction, the signals are faint, spread thin, and quickly dissolve into background noise once you move any meaningful distance away. The notion that extraterrestrials have picked up our television transmissions and are now heading toward Earth belongs to science fiction, not to physics. For any alien civilization to receive a signal from Earth, they would have to exist inside that 100 light-year bubble. They would need to be listening at precisely the right frequency. They would need instruments sensitive enough to detect signals that are extraordinarily weak. And even if every one of those conditions were satisfied, any reply they sent would take decades or centuries to reach us. If a civilization 50 light-years away detected our earliest radio broadcasts and responded immediately, their message would arrive 100 years after the original transmission. We would be hearing their reply now, long after we had forgotten sending anything that seemed worth answering. The search for extraterrestrial intelligence, SETI, has been surveying the sky for artificial signals since 1960. For more than 6 decades, with ever more advanced technology, it has examined billions of frequencies and monitored millions of star systems. The outcome has been complete silence. Not a single confirmed signal of artificial origin, not one clear indication that anyone else is transmitting out there. This lack of evidence does not prove that extraterrestrials do not exist, but it does place limits on what is possible. Either intelligent civilizations are exceedingly rare, or they do not emit signals we can detect, or those signals have not yet reached us, or something entirely unforeseen is at work. Travel between stars presents challenges even more severe than communication. We have already considered the travel times involved, measured in millennia at speeds we are currently capable of reaching. But suppose we imagine going faster. The energy required to accelerate a spacecraft rises dramatically as it approaches the speed of light. To accelerate a relatively small spacecraft with a mass of 100 kilograms to just 10% of light speed would demand an amount of energy comparable to the total yearly energy use of all human civilization. Reaching 50% of light speed would require vastly more. Approaching light speed itself would demand infinite energy, which is precisely why nothing with mass can ever attain it. Even if an alien civilization possessed energy resources far beyond anything we can imagine, the underlying physics remains unchanged. They might manage to travel at 10% of light speed, or 20%, perhaps even 50%, with technology that borders on the divine, but they cannot surpass the speed of light. A civilization located on the far side of the Milky Way, traveling at half the speed of light, would still need 200,000 years to arrive here. That is not a voyage any biological organism could endure. It is not a mission any society could maintain. The individuals who set out would have been gone for thousands of generations before arrival. Some propose the idea of generation ships, vast vessels in which successive generations are born, live, and die during the journey, with distant descendants eventually reaching the destination. This addresses the problem of individual lifespans, but introduces deeper difficulties. What kind of social system could preserve its purpose over thousands of generations? What technology could operate reliably for hundreds of thousands of years without catastrophic failure? What motivation would sustain the 100th generation, who never knew the home world and will never see the destination, to continue maintaining systems for descendants they will never meet? These are not merely engineering problems. They challenge the very idea of maintaining shared purpose across timescales that vastly exceed all human experience. Others imagine faster-than-light travel using wormholes, warp drives, or other exotic ideas from theoretical physics. Such concepts do appear in the equations of general relativity, but they require conditions that may be physically unattainable. Wormholes would demand exotic matter with negative energy density, something that may exist only fleetingly at microscopic quantum scales. Warp drives would require the manipulation of space-time itself, calling for energy amounts greater than the mass energy of entire stars. These are not technologies waiting patiently to be invented. They are mathematical possibilities that almost certainly cannot be realized in the real universe. So when we ask whether humans will ever encounter extraterrestrials, we must be clear about what we are really asking. Not whether life exists elsewhere, which seems likely given the vast numbers involved. Not whether intelligence could have evolved on other worlds, which remains plausible. The real question is whether two intelligent species, emerging on different planets around different stars, could ever find themselves in the same place at the same time in a universe that appears structured to keep everything apart. The distances say no. The laws of physics say no. The timescales say no. Every measurement we can make and every calculation we can trust points to the same conclusion. Intelligent species, if they exist at all, are likely to be isolated outposts scattered through space and time, separated by distances so immense that no meaningful bridge could ever be built between them. We may share the universe with innumerable thinking beings and yet remain forever alone, divided not by hostility or neglect, but by the sheer scale and geometry of the cosmos itself. There is something profoundly unsettling about that idea. For centuries, humanity has dreamed of contact with beings from other worlds. We have told stories, made films, and even shaped belief systems around the possibility. The thought of encountering alien intelligence has inspired hope, fear, and awe in equal measure. Sometimes, we imagine visitors who arrive bearing knowledge and technology beyond our own. Sometimes we imagine conquerors who bring destruction. At other times, we picture enigmatic watchers whose intentions we cannot comprehend. What we have struggled to accept is a far simpler possibility. That contact may be impossible, not because life is rare, but because the universe itself forbids it. The ultimate speed limit of the cosmos changes everything about how we think of extraterrestrial life. In a universe where matter and information could move instantly, contact would be almost unavoidable given enough time. But this is not such a universe. Here, the speed of light is absolute. Distance and time are inseparably linked. To cross the gap between stars requires either journeys lasting thousands or millions of years, or forms of physics that almost certainly do not exist. Under these conditions, contact becomes extraordinarily unlikely, no matter how common life might be. This is the first and most fundamental barrier to meeting aliens. Not technology, not desire, not even the challenge of finding one another. It is simply the structure of space-time itself, which places everything at distances that expand faster than any conceivable way of traversing them. And this is only the beginning of the difficulty. There is another aspect of the problem that is often overlooked when people imagine communication with alien civilizations. We focus on distance, on the vast number of light years between star systems, on the near impossibility of crossing those gulfs. But there is another separation that may be even more impossible to overcome: time. Not just travel time, although that matters. I mean the timing of existence itself. The universe is 13.8 billion years old. Human civilization has existed for perhaps 10,000 years. We have had radio technology for roughly 100 years. The period during which we are detectable, the brief moment when we can send or receive signals across interstellar space, is so tiny compared to cosmic timescales that it almost vanishes when you try to visualize it. Let me give you a sense of scale. Imagine compressing the entire history of the universe into a single calendar year, with the Big Bang occurring at midnight on January 1st. The Earth would not form until September 2nd. Life would appear around September 21st. Dinosaurs would dominate from December 25th to December 30th. Modern humans would emerge at about 11:52 p.m. on December 31st. All of recorded human history would fit into the final 14 seconds before midnight. Our technological civilization, our ability to broadcast signals into space, would occupy roughly the last 0.1 second. That is our window of detectability on the cosmic calendar. That fleeting instant is how long we have been capable of announcing our presence to the universe. And for anyone else to receive those signals, they would need to be listening at that same cosmic moment, in exactly our direction, with technology sensitive enough to detect our faint emissions across the void. Now imagine another civilization somewhere in the galaxy. Perhaps it arose on a planet orbiting a star that formed 8 billion years ago, long before our sun existed. Perhaps it developed technology, built vast societies, and sent signals into space, hoping for an answer. Perhaps it listened for millions of years and heard nothing. Eventually, it may have gone extinct, abandoned its technology, or evolved into something that no longer cared to communicate with young, primitive civilizations that had not yet appeared. By the time humanity built its first radio transmitters, that civilization might have been gone for 3 billion years. Any signals it sent would have swept past our region of space long before Earth hosted complex life, washing over a world of bacteria and archaea that could never have noticed. Or consider the opposite case. A civilization may be emerging right now on a planet 50,000 light years away. They might be at roughly our level, just beginning to transmit signals, just beginning to ask whether they are alone. Their signals will not reach us for 50,000 years. Ours will not reach them for the same length of time. By the time any exchange could occur, 100,000 years will have passed. What will humanity be then? Will we still exist? Will we still use radio? Will we even care about communicating with other species? This is the temporal paradox at the heart of interstellar communication. Even if intelligent civilizations are relatively common, perhaps arising once for every million stars, they must exist at the same time and remain technologically detectable during overlapping windows. The chance that two civilizations are both in that brief phase, close enough to detect one another, is far smaller than the chance of either civilization existing at all, and we should reflect on how fragile such phases may be. We have had advanced technology for about a century. In that same span, we have created nuclear weapons, driven planetary climate change, and gained the ability to destroy ourselves in multiple ways. It is entirely possible that technological civilizations are inherently unstable, that the same intelligence that allows a species to build radio transmitters also enables it to build the tools of its own extinction. If the average technological civilization survives for only a few thousand years before either destroying itself or abandoning technology, then the Milky Way could have hosted millions of such civilizations throughout its history without any two ever existing at the same time. In 1950, during an ordinary lunch conversation, a simple but profound question was raised. Where is everybody? That question came to embody a deep puzzle, the tension between the high probability that intelligent life should exist elsewhere and the complete lack of any evidence that it does. Many explanations have been suggested, but one of the most persuasive is the idea of temporal isolation. Civilizations may be widespread across cosmic history, yet extraordinarily rare at any single moment. The galaxy could be littered with the remnants of extinct societies. Their signals have long since vanished, their planets fallen silent, their technologies reduced to dust. It is entirely possible that we are moving through a cosmic graveyard, surrounded by the remains of species that rose and fell while our own ancestors were still single-celled organisms drifting in ancient oceans. And even civilizations that avoid self-destruction are constrained by time. Stars are not eternal. Our sun will begin to die in about 5 billion years, swelling into a red giant and making Earth uninhabitable. Any civilization bound to a single star system has a finite lifetime, measured at most in billions of years, and usually far less once you consider the gradual brightening of stars that renders planets hostile to life long before stellar death. Earth's remaining window of habitability may be only 1 to 2 billion years. To us, a billion years feels like an eternity, yet it is less than 10% of the universe's current age, and a negligible fraction of the trillions of years the universe is expected to endure. There is also the question of what, exactly, we are searching for. When we listen for other civilizations, we listen for radio waves, because that is the technology we understand. But radio communication may represent only a brief moment in a civilization's technological evolution. We have used it for roughly a century, and even now, we are moving away from broad radio broadcasts toward tightly directed signals and fiber optic systems that leak very little into space. A civilization just 1,000 years more advanced than ours might rely on forms of communication that are completely invisible to our detectors. They could use lasers, gravitational waves, quantum effects, or methods not yet imagined. Their silence may not mean extinction, but simply progress. They may have discovered more efficient ways to communicate that do not involve flooding the cosmos with electromagnetic radiation. In 1961, an equation was proposed to estimate how many detectable civilizations might exist in our galaxy. It combines factors such as the rate of star formation, the proportion of stars with planets, the fraction of planets that develop life, the fraction of life that becomes intelligent, the fraction that develops detectable technology, and the length of time those civilizations remain detectable. Early, optimistic estimates suggested that thousands of civilizations might be visible across the Milky Way, but the true value of the equation lies in how clearly it exposes our ignorance. We simply do not know most of these numbers. We guess, and those guesses vary by many orders of magnitude. The most uncertain term, and perhaps the most crucial, is the duration for which a civilization remains detectable. If that time span lasts millions of years, the galaxy should be alive with signals. If it lasts only a few centuries, then most civilizations fall silent long before their signals ever reach another listener. At present, our own detectable phase is about 100 years old. Whether that will stretch into thousands or millions of years, or end tomorrow in catastrophe, is impossible to know. But the fact that more than 60 years of searching has revealed nothing suggests either that technological civilizations are exceedingly rare, or that their detectable lifetimes are usually very short. Some have even suggested that we may be among the first technological civilizations to emerge in the Milky Way. The universe itself needed time to make this possible. The earliest stars were composed almost entirely of hydrogen and helium. When they died as supernovae, they forged and scattered heavier elements, such as carbon, oxygen, and iron, the raw materials of planets and life. Later generations of stars incorporated these elements, and this process unfolded over billions of years. Earth formed about 4.5 billion years ago, roughly 9 billion years after the Big Bang. It may be that this is close to the minimum time required for a technological civilization to arise. Perhaps we are not arriving late to a long-finished gathering, but early to one that is only just beginning. If so, we may be among the first species in our galaxy to develop advanced technology. Not the final survivors in a universe filled with ancient ruins, but pioneers in a cosmos that has not yet had time to fill with intelligent life. It is a different kind of loneliness. Rather than being separated from other civilizations by vast distances, we may be separated by vast stretches of time. The civilizations we might one day communicate with may not exist yet. They could be billions of years away from evolving. By the time they do, humanity itself may be long gone. Our signals dissolved into background noise, our existence erased. Time isolates just as effectively as distance. Two civilizations could be close neighbors in space, orbiting stars only a few light years apart, near enough that messages would take years rather than millennia to travel. Yet if they are separated by time, they will remain forever unaware of one another. If one civilization blossomed and vanished 500 million years ago, and another will not emerge for another 500 million years, then, for all practical purposes, they exist on opposite edges of reality. They can never encounter one another. They can never exchange a message. They can never even be aware that the other once lived. The timeline of the universe is so immense that existing at the same moment becomes as unlikely as being close together in space. This is the second profound obstacle to encountering extraterrestrial life. It is not only the separation between stars that matters, but the separation between moments. The universe has been here for nearly 14 billion years and will persist for trillions more. Any single civilization occupies only a fleeting fragment of that vast continuum. The likelihood that two such fragments overlap, that two species arise at the same time in a cosmos marked by endless extinctions and rebirths, may be vanishingly small. So, regardless of how abundant life itself may be, we scan the heavens for signals that could have been transmitted thousands of years ago by beings who might have disappeared millions of years before that. We send messages that will not arrive for centuries, hoping someone will still exist to receive them, fully aware that we ourselves will not be here to hear any reply. This is what communication across cosmic distances and cosmic timescales truly is. It is not dialogue. It is not even correspondence. It is more like messages sealed in bottles and cast into an ocean so vast that no bottle has ever reached a shore, and perhaps no shore exists to receive them. The isolation of civilizations in time may be the simplest resolution to the Fermi paradox. We see no evidence of alien civilizations because none may be active right now within a range we can detect. The galaxy may have hosted countless civilizations throughout its history, but compared to cosmic timescales, they ignite and fade with astonishing speed, making overlap extraordinarily rare. We are not alone in the universe. We are alone in time. And time, like distance, is a barrier that no technology can defeat. But suppose, just for a moment, that we overcome these first two barriers. Imagine there is a civilization somewhere in the galaxy right now, close enough for signals to travel within reasonable times, technologically active, deliberately broadcasting into space. Let us grant every hope of the optimists. Picture a civilization within 100 light years, transmitting powerful signals, genuinely attempting to make contact. Even then, even under the most generous assumptions, we confront a problem so fundamental that it may render communication impossible, regardless of distance or timing. That problem is understanding, or more precisely, recognizing alien communication as communication at all. When we think of aliens, we tend to picture versions of ourselves. Popular culture has conditioned us to expect humanoid figures with altered skin tones, unusual foreheads, or different numbers of fingers. We imagine beings who speak languages we might one day learn, who possess motivations we could eventually grasp, who perceive reality in ways sufficiently similar to our own that meaningful dialogue could occur. This is almost certainly mistaken. It is a failure of imagination so deep that it could doom any attempt at interspecies communication before it even begins. Look at the diversity of life on Earth. All of it shares the same underlying biochemistry, the same genetic code, the same evolutionary past. Take the octopus. It has 9 brains, 1 central brain, and 8 distributed throughout its arms. Each arm can act with a degree of independence, tasting, sensing, and deciding without consulting the central brain. An octopus experiences reality in ways that stretch our imagination, despite being a distant relative, despite sharing 33% of our genes. We have shared this planet with octopuses for hundreds of millions of years, and we still cannot communicate with them in any meaningful way beyond the most rudimentary level. Dolphins possess language, or something remarkably close to it. They have signature whistles that function like names. They understand grammar, follow complex instructions, and recognize themselves in mirrors. By any reasonable standard, they are intelligent. We have studied them intensively for decades, and yet we cannot hold a conversation with a dolphin. We do not know what occupies their thoughts. We do not know whether they form abstract ideas, whether they reflect on death, or whether they ever gaze upward in their own way and wonder about the stars. They are intelligent beings on our own planet, breathing the same air, moving through our oceans, and they remain profoundly alien to us. Now imagine a species that evolved on an entirely different world, under wholly different conditions, with unfamiliar chemistry and utterly distinct evolutionary pressures. They would not share our evolutionary story. They would not share our genetic code. They might not even use DNA, proteins, or anything we would recognize as biology. Their intelligence, if that word even applies, could operate on principles entirely outside our understanding of minds. What would intelligence look like if it evolved in a methane ocean on a frozen moon? What if it were a collective entity, a hive mind with no individual awareness? What if it experienced time differently, living so slowly that all of human civilization would pass like a fleeting instant, or so rapidly that our years would seem like vast epochs? What if it perceived electromagnetic radiation beyond the narrow band we see, experiencing the universe through radio waves, X-rays, or wavelengths we have not yet named? What if it communicated using chemical signals, gravitational disturbances, or methods completely undetectable by any instrument we have built? The assumption that extraterrestrial civilizations would communicate using radio waves is rooted entirely in our own technological history. Radio waves are effective for communication because they travel through space at the speed of light and can carry information. We assume that any advanced civilization would discover this and use it, just as we have. But that assumption rests on the belief that other intelligences would follow technological paths similar to our own. It presumes minds, equipped with senses, for which radio waves are obvious and useful. It presumes a desire to communicate at all. We transmit radio signals because we evolved as social beings, dependent on communication for survival. Our brains are tuned for language in ways that shape how we think, perceive, and understand the world. We instinctively find patterns in noise, meaning in symbols, and stories in sequences of events. That tendency is not universal to intelligence. It is particular to human intelligence, forged by millions of years of evolution as social primates whose lives depended on cooperation with others. An intelligent species that evolved as a solitary predator might possess no concept of communication whatsoever. Such beings could be extraordinary problem solvers, capable of advanced technology and deep understanding of physics, yet entirely uninterested in sharing information with anyone else. They would have no motivation to transmit signals and no reason to search for them. They might regard the idea of interstellar communication in the same way we view the social behavior of bacteria as something far beneath their concern. Even species that do communicate may do so in forms we would never recognize. Human language relies on discrete symbols arranged by grammatical rules. That structure feels natural to us, but it is simply the result of our particular cognitive architecture. Other intelligences might communicate through continuous signals rather than distinct symbols. They might exchange information through direct neural connection, bypassing symbols entirely. They could communicate by altering shared environments, through distributed computation, or by methods that do not resemble anything we would call language. In 1977, the Voyager spacecraft were launched, carrying golden records filled with sounds and images from Earth. They were messages intended for any alien civilization that might one day encounter them. Those records contain greetings in 55 languages, natural sounds such as thunder and birdsong, music from many cultures, and images of humans and our planet. It was a profoundly human gesture, yet imagine how strange it might appear to a non-human intelligence. The sounds presume hearing within human frequency ranges. The images assume vision based on reflected light. The languages presume symbolic communication structured like our own. The music presumes emotional responses shaped by human neurology. An alien discovering the Voyager record might not even recognize it as a message. They could see it as an odd artifact, a fragment of debris, something to catalogue and forget. Even if they sensed intention behind it, they might be unable to decode it. Human images depend on visual conventions that are culturally learned. Even among ourselves, some cultures read from left to right, others from right to left. We interpret perspective, shading, and proportion through assumptions we acquire over time. Minds with entirely different perceptual systems might see nothing but meaningless patterns where we see photographs of people. The same challenge applies to any signal we might receive. The search for extraterrestrial intelligence looks for patterns in electromagnetic radiation, for signals with mathematical structure or repetition that nature alone is unlikely to produce. But what if alien communication does not appear as patterns to us at all? What if it is organized in ways that our pattern recognition systems, evolved for entirely different purposes, simply cannot detect? It is conceivable that we are immersed in alien communications right now, signals passing through Earth constantly, and we are utterly blind to their meaning. Mathematics is often suggested as a universal language, something any technological civilization must grasp. The ratio of a circle to its diameter, the behavior of prime numbers, the relationships among physical constants, these are the same everywhere in the universe. Any civilization capable of building radio transmitters must engage with mathematics. So we assume that if we send mathematical messages, they will understand them, and if they send such messages, we will recognize them. Yet, mathematics, as we practice it, is a human creation. The symbols we choose, the way we construct proofs, and the concepts we emphasize all reflect human cognitive biases and historical chance. Even the idea of number may not be fundamental to every intelligent mind. Some human cultures function without words for numbers beyond 3 or 4. They solve real-world problems effectively using methods that do not rely on abstract numerical systems. An alien intelligence might develop entirely different mathematical frameworks that solve the same physical problems but look nothing like ours. Even if alien beings use something we would identify as mathematics, translating between systems could be extraordinarily difficult. Imagine trying to communicate with a civilization whose mathematics is built on continuous processes rather than discrete quantities, or whose geometry exists without the concept of points, or whose physics is framed in ways we have never conceived. Their scientific results would still be correct. Their bridges would stand, their spacecraft would function, but the conceptual language they use to describe reality could be utterly unfamiliar. There is also the deeper question of what intelligence itself really means. We tend to define intelligence by what humans excel at. Problem solving, abstract thought, tool making, and language are skills that mattered for our survival, so evolution favored them. We take these traits and call them the hallmarks of intelligence, but that definition folds back on itself. We judge other minds by comparison with our own and then declare ourselves the benchmark. A species shaped by entirely different conditions could possess cognitive abilities utterly unlike ours. It might have flawless memory, yet no ability for abstraction. It might excel at spatial reasoning while lacking any notion of time. It could process information in vast parallel networks, something we might label intelligent, yet produce nothing resembling individual consciousness or self-awareness. It might be intelligent in forms we would never detect, simply because our senses and concepts are not tuned to perceive them. This is the third barrier to encountering alien life. Not only the separation of stars or the alignment of civilizations in time, but the conceptual chasm between minds that evolved independently. Two intelligent species could exist within the same galaxy, even within neighboring star systems, exchanging signals for thousands of years and still fail to achieve meaningful communication. Their intelligences might be so different that no bridge can be built. Each might conclude it is alone in the universe, dismissing the other's signals as meaningless noise, while in reality, another mind is right there, speaking a language that does not register as language at all. When we search for intelligence, we look for reflections of ourselves. We expect aliens to build radio transmitters because we did. We assume they will value communication because we do. We presume their minds will function closely enough to ours that understanding is possible. Every one of these assumptions could be wrong. The universe may be filled with intelligent beings we would never identify as intelligent, sending signals we would never recognize as signals, aware of us in ways we would never interpret as awareness. This idea is at once humbling and profoundly isolating. We may not be alone, we may be surrounded by alien minds, yet the differences between them and us could be so vast that contact, in any meaningful sense, is impossible. Not because of physics, not because of timing, but because the very idea of contact demands shared ground that may not exist between minds, shaped separately in a universe with limitless room for variation. We have considered the barriers of distance, time, and comprehension. But there is another possibility to confront, one that is darker and perhaps more plausible than we might like. What if intelligent civilizations are simply rare? Not rare in the sense of one per galaxy, which would still imply billions across the observable universe, but rare in a way that truly limits our chances of contact. What if the emergence of intelligent technological life is so unlikely that it almost never occurs? What if we are not separated from others by distance, time, or cognition, but by the simple reality that there are no others at all? The physicist Enrio Fermi's famous question, "Where is everybody?" has inspired dozens of proposed answers over the decades. Yet one explanation stands out for both its power and its unsettling implications: the Great Filter, introduced by economist Robin Hanson in 1996. This idea suggests that somewhere between inert matter and civilizations spanning galaxies lies a hurdle so extreme that almost nothing ever passes it. Some step in the chain from chemistry to biology to intelligence to technology to interstellar expansion is so improbable that it effectively never happens. The crucial question is where this filter sits. If it lies behind us, then we are extraordinarily fortunate. The transition from non-living chemistry to life itself may be so unlikely that it occurred only once in our galaxy, or only a handful of times in the entire universe. Or the bottleneck could be the rise of multicellular life, or the emergence of intelligence, or the invention of technology. If any one of these steps is sufficiently improbable, then we may be alone not because civilizations inevitably destroy themselves, but because they almost never arise. Look at what we know of Earth's own history. Our planet formed about 4.5 billion years ago. Life appeared remarkably quickly, within the first billion years, perhaps even within the first few 100 million. This suggests that given suitable conditions, life may emerge readily, and that the jump from chemistry to biology may not be the filter. But consider what followed. For roughly 3 billion years, life remained single-celled. Bacteria and archaea, simple organisms performing simple tasks, dominated for 34 of life's entire history on Earth. Multicellular life did not appear until around 600 million years ago. Complex animals arrived even later, about 540 million years ago, during the Cambrian explosion. This pattern hints that the rise of complex life may be extraordinarily difficult. Single-celled life emerged quickly. Complex life required billions of years, and we do not know whether it was inevitable or the result of a rare stroke of luck. The specific event that enabled complexity on Earth, the merging of two distinct cell types to form the eukaryotic cell with its mitochondria, may have been so improbable that it occurred rarely, if ever, elsewhere. Without that merger, life might remain forever bacterial, forever simple, forever incapable of building bodies, brains, or civilizations. Or we can turn our attention to intelligence itself. Life has been present on Earth for almost 4 billion years. Across that immense span of time, on a planet overflowing with life in every imaginable environment, intelligence at a human level emerged only once, not repeatedly, not across different branches of life arriving at the same solution, just once. Dinosaurs ruled the planet for 165 million years and never produced anything resembling technology. Had the asteroid not arrived 66 million years ago, they might still dominate the Earth today, and we might never have appeared at all. This suggests something deeply unsettling. Intelligence may not be an inevitable product of evolution. It may be an extraordinary accident, a random wandering path that happened just once to arrive at this outcome on this particular world, and almost never arrives there anywhere else. And even when intelligence does arise, technology is far from guaranteed. Our own species possessed human-level intelligence for at least 200,000 years before anything like a technological civilization emerged. For the vast majority of that time, we lived as hunter-gatherers, small groups moving across landscapes, shaping tools from stone and bone, but never building cities, never writing, never practicing science. The transition from intelligence to technology required a precise combination of circumstances. Control of energy sources such as fire, materials that could be shaped into tools, social systems capable of preserving and transmitting knowledge across generations, a stable climate that allowed agriculture to take root. Any one of these could be the narrow gate that prevents an intelligent species from becoming a technological one. And this is where the idea of the Great Filter becomes profoundly disturbing. The filter may not lie behind us. it may still be ahead. Life itself might be common. Intelligence might arise again and again. Technological civilizations might appear on thousands of worlds throughout the galaxy, and yet something may stop every one of them from ever spreading beyond their home planet. Perhaps they all destroy themselves. Seen through this lens, our own civilization takes on a far more precarious appearance. We have possessed nuclear weapons for less than 80 years, and in that short time we have already come terrifyingly close to annihilating ourselves on multiple occasions. The Cuban Missile Crisis, the 1983 Soviet nuclear false alarm, when Stanislav Petrov chose to distrust his instruments, which were telling him that an American nuclear strike was underway. Again and again, accidents, misunderstandings, and moments of human fallibility have pushed us to the edge. We now wield technologies capable of engineering pathogens that could unleash global pandemics. We are developing artificial intelligence that some researchers fear could pose existential risks if it moves beyond human control. At the same time, we are altering the climate in ways that threaten to destabilize the very systems upon which our civilization depends. Perhaps this pattern is universal. Perhaps every technological civilization follows a similar arc. They unlock nuclear energy and create nuclear weapons. They develop biotechnology and biological weapons. They create artificial intelligence that slips beyond their command. They push their planet's climate past irreversible thresholds. They deplete essential resources before alternatives are ready. They fracture into rival groups and engage in conflicts of unprecedented destructive power. The same intelligence that allows a species to build a radio transmitter also enables it to construct weapons capable of ending its own existence. And perhaps this is true everywhere. Every species that reaches this stage destroys itself before it can ever reach the stars. That alone would explain the silence. The galaxy is not quiet because life is rare. It is quiet because intelligent life is self-destructive. Civilizations emerge, blaze briefly, and then extinguish themselves in an evolutionary heartbeat. The cosmic calendar does not show a long, empty universe interrupted by a thin sliver of human existence. Instead, it shows a continual flickering of short-lived flames, civilizations igniting and fading across billions of years, never lasting long enough to expand, never surviving long enough to be noticed. Of course, there are other possibilities. Perhaps civilizations do not destroy themselves, but transform in ways that render them invisible. Perhaps they abandon physical reality altogether, uploading consciousness into virtual worlds. Perhaps they reach such profound equilibrium that exploration and expansion lose their appeal. Or perhaps they deliberately conceal themselves, either from dangers we do not yet understand, or from one another, having learned that contact between civilizations tends to end in violence. This final idea is often referred to as the dark forest hypothesis, named after a science fiction novel by Chinese author Liu Cixin. It imagines the universe as a dark forest filled with hunters. Any civilization that reveals its location risks being eliminated by another that sees it as a potential threat. In such a universe, the safest course is silence. Do not broadcast. Do not respond. Remain hidden in the cosmic darkness. If this is correct, then the search for extraterrestrial intelligence is not merely futile, it is dangerous. Every signal we transmit is an announcement of our presence. Every attempt to listen might draw the attention of something that would rather we were gone. The dark forest hypothesis may sound paranoid, but it follows logically from certain assumptions. If resources in the universe are finite and civilizations compete for them, then every other civilization is a potential rival. If it is impossible to accurately judge another civilization's capabilities from afar, then every other civilization is a potential threat. If communication across interstellar distances takes so long that trust cannot be established, then caution becomes survival. In such a cosmos, civilizations that announce themselves are erased. Those that hide endure, and what remains, from our vantage point, is silence. We do not yet know which explanation for the Great Silence is the right one. It may be that life itself is exceptionally rare. It may be that intelligence is the rarity. It may be that technological civilizations tend to destroy themselves. Perhaps they deliberately conceal their existence. Perhaps they move beyond forms we can perceive or communicate with. Or perhaps they exist in ways that our minds and instruments simply cannot recognize. It may also be that the universe is so vast and so ancient that contact between isolated species, each flashing briefly into existence before fading away, is extraordinarily unlikely. Every one of these ideas fits the evidence, or more precisely, fits the absence of evidence. What we can say with confidence is that the silence is real, and it demands an explanation. The universe has existed for nearly 14 billion years. The Milky Way contains hundreds of billions of stars, many of them older than the Sun, and many of them surrounded by planets. If technological civilizations emerged, even rarely, and endured even for short periods, the galaxy ought to bear traces of them. We would expect signals, artifacts, engineering projects on truly cosmic scales. But we see none of this. The galaxy is quiet, and that quiet insists on an answer. The most disturbing possibility is that we ourselves are that answer, that we are the first, or perhaps the only, technological civilization in our galaxy, an improbable accident on an otherwise unremarkable planet, alone not because others hid or vanished, but because no others ever existed. In this picture, the great filter lies behind us. We have already passed whatever bottleneck leaves the universe so empty. We are the survivors, the fortunate ones, the exception that reveals just how rare technological life may be. If this is true, it places an immense responsibility on our species. We are not merely one civilization among many. We are the only one, the only beings in this galaxy capable of reflecting on the cosmos, of building instruments to explore it, of asking what our existence means. If we destroy ourselves, if we fail to endure the centuries ahead, the galaxy falls back into emptiness. The experiment of intelligence in this region of the universe ends, and there may be no one else to begin it again. This is the weight of the Fermi paradox. It is not simply a puzzle for physicists. It is an existential question about intelligence itself and the fate of civilizations. Why are we alone? Are we alone? Will we always be alone? The silence of the cosmos presses in from every direction, and each explanation for that silence carries consequences we can scarcely grasp. Perhaps the answer is that encountering extraterrestrial intelligence is impossible, not because of one single obstacle, but because of all of them acting together. Distance makes travel impractical. Time makes coincidence improbable. Differences in cognition may make communication impossible. And the great filter, wherever it lies, ensures that civilizations capable of attempting contact are vanishingly rare or painfully short-lived. Each barrier strengthens the others. Together they form a wall that may be truly insurmountable, sealing every intelligence within its own bubble of space and time, forever alone in a universe beyond imagination. We have examined these barriers one by one, the distances that even light takes years or centuries to cross, the timescales that make overlapping civilizations unlikely, the cognitive gaps that could render communication meaningless even if contact occurred, the filters, whether in our past or our future, that might explain why the universe appears devoid of intelligent life. Any one of these obstacles would make meeting alien civilizations extraordinarily unlikely. Taken together, they suggest an impossibility that is hard to dismiss. And yet, I find this conclusion deeply unsatisfying. Not because it is necessarily wrong. The physics is real, the timescales are real, the silence is real. But because the question of alien life reaches beyond scientific curiosity, it touches our understanding of who we are and what our existence signifies in a universe so vast that even our most powerful telescopes reveal only a small fraction of it. For most of human history, we believed ourselves to be at the center of everything. The Earth stood at the center of the universe. The sun and stars revolved around us. Humanity was the pinnacle of creation, the reason the cosmos existed at all. Slowly, and often painfully, science dismantled these beliefs. Copernicus showed that Earth orbits the sun. Galileo revealed that the sun is merely one star among many. Hubble demonstrated that the Milky Way is just one galaxy among billions. Each discovery displaced us further from the center, diminished our sense of importance, and exposed our cosmic smallness. In many ways, the search for extraterrestrial life is the final step in this journey. If we discover that intelligence is widespread, that civilizations arise throughout the universe, then we will know that we are not special at all. We are not the purpose of the cosmos. We are simply one outcome of chemistry becoming complex enough to reflect upon itself. That would be humbling, but also reassuring. We would belong to something larger. Even if we could never communicate with it, we would not be alone. But if we continue to search and find nothing, if the silence endures through centuries of ever more sensitive observation, we will confront a very different truth. We may be unique, not unique in the trivial sense of fingerprints or DNA, but unique in a far deeper and more profound way. The only thinking minds in a galaxy of 400 billion stars. Perhaps the only thinking minds in an observable universe of 200 billion trillion stars. That would make us not insignificant, but astonishingly important. A solitary flame of consciousness, burning in an otherwise dark cosmos. Both possibilities are unsettling in different ways. Our thoughts are commonplace. Our existence is unexceptional. If we are alone, then our extinction would bring an end to something unique, something that cannot be replaced, plunging the universe back into a darkness that might never lift. We often ask whether we will ever encounter extraterrestrial life. But perhaps the deeper question is what it means if we never do. Think about what we know of the universe. It has been expanding for 13.8 billion years. It contains structures stretching across hundreds of millions of light years. It is governed by physical laws of extraordinary precision and mathematical elegance. Quantum mechanics tells us that particles can exist in multiple states until they are observed. General relativity describes space-time itself, bending and curving under the influence of mass. The universe appears almost as if it is made to be understood, filled with patterns and regularities that yield to mathematics. And yet, for most of its history, as far as we know, there was no one there to understand it. Stars were born and died for billions of years before life appeared anywhere at all. Galaxies collided and merged in vast cosmic events that no eye ever saw. The fundamental laws of physics operated perfectly, without any mind capable of discovering them, for 13.8 billion years. The universe was a performance without an audience, a story without a reader, a question with no one to ask it. Then, on a small planet orbiting an ordinary star in an unremarkable galaxy, chemistry turned into biology. Biology gave rise to complexity. Complexity gave rise to awareness. And for the first time, the universe had witnesses. Beings that could look up into the night sky and wonder. Minds that could work out the age of the cosmos, the composition of distant stars, the destiny of galaxies billions of light years away. Intelligences capable of understanding the universe while remaining confined to a single fragile world within it. If we are alone, then the emergence of consciousness in a universe that did not need it takes on enormous significance. We are not merely one species among many. We are the universe becoming aware of itself. The cosmos, looking back on its own history, the laws of physics, discovering that they exist. It may sound mystical, but it is simply a description of what has happened. Matter has arranged itself into patterns complex enough to understand the rules that govern matter. We are those patterns. And if we are the only such patterns in the entire vast cosmos, then our existence borders on the miraculous. Many people find comfort in believing that extraterrestrial life must exist somewhere, that the numbers are simply too large for life to have arisen only once. And perhaps they are right. Perhaps civilizations are scattered throughout the universe, separated by such immense distances that they may as well inhabit entirely different universes. Perhaps, right now, beings on a planet 10 billion light years away are having this same discussion, wondering if they are alone, concluding that they must be, because the cosmos is too vast for contact. Perhaps every intelligent species reaches this moment, looks out into the silence, and feels the same mixture of wonder and loneliness that we feel. but the silence persists. 60 years of SETI and nothing. Hundreds of billions of stars in our galaxy and no signals. Trillions of planets and no visitors. We can speculate endlessly about the reasons, but we cannot avoid the central observation. As far as we can detect, as far as we can measure, as far as we can determine, with every instrument we have built and every search we have conducted, we are alone. This may be a temporary condition, the result of limited technology and a brief search, or it may be the permanent truth of our existence. So what do we do with that knowledge? How do we live in a universe where meeting extraterrestrial intelligence may be genuinely impossible? For some, this is a reason for despair. All our dreams of first contact, of learning from ancient civilizations, of joining a galactic community, would be fantasies that can never be fulfilled. We would be confined to this single planet, in this single solar system, alone with ourselves for as long as our species survives. But there is another way to see it. If we cannot meet others, then the future of intelligence in our region of the universe depends entirely on us. There is no one else to carry the torch if we let it fall. No other civilization will build the telescopes, ask the questions, or seek the answers. We are it. The responsibility is ours, and it extends not just across our planet, but potentially across light years of space that might otherwise remain forever devoid of minds. The loneliness is real, looking up at the stars and realizing that we may never encounter anyone else, that all those points of light might circle only dead rocks and sterile gas giants, that the universe could be a vast, empty house with us as its only inhabitants. This loneliness is the price of cosmic awareness. Animals do not feel it because they do not know enough to feel it. Only a mind that can grasp the universe is capable of feeling alone within it. Yet that loneliness is not empty. It is the outline of our circumstance. It defines the problem set before us, and there may be a quiet dignity in confronting it without illusion, in continuing the search even when the silence feels complete, in sending messages even when no reply is expected, in constructing instruments that probe ever deeper into the darkness. We search not because discovery is assured, but because searching is the natural activity of an intelligent mind. We ask questions not because answers are promised, but because inquiry is how understanding begins. We reach outward not because someone must be there, but because reaching outward is how we express what we are. The universe may contain no other thinking beings at all. We may truly be alone, separated by immense distances, by deep time, by the fragile conditions that allow intelligence to emerge and endure. Encountering other civilizations may be not merely unlikely, but fundamentally impossible, constrained by the very architecture of the cosmos. If that is so, it does not diminish our value, it elevates it. It makes us extraordinarily rare, the only entities anywhere capable of reflecting on beauty, of experiencing love, of creating meaning, of asking why, the sole witnesses to a universe that would otherwise pass unseen. When I look at the night sky now, I perceive something different from what I once did before considering these possibilities. I see distances that defy comprehension, timescales beyond imagination, a silence that resists explanation. I see a cosmos that may be filled with countless minds, or one that may contain only us. I see questions that may never find answers, searches that may never reach their goal, hope that endures even when the evidence suggests it should not. And I see something more. I see stars that will continue to shine whether anyone observes them or not. I see galaxies that will carry on with their ancient collisions whether or not they are ever witnessed. I see a universe that exists, that functions, that unfolds according to its laws, entirely independent of whether any mind ever understands it. We may be alone, we may be the only beings who will ever ask that question, but the act of asking matters. The act of wondering matters. Reaching into the darkness matters, even if nothing ever reaches back. This is our condition. This is what it means to be conscious in a universe that does not require consciousness. We may never encounter other intelligences. We may spend our entire existence as a species wondering about others who do not exist, but we will continue to wonder. We will continue to search. We will continue to transmit signals, to build telescopes, to ask questions, because that is what minds do. And if we are the only minds that exist, then we carry a responsibility to be the best minds we can be, to ask the deepest questions, to look toward the most distant horizons, to let our brief flame of awareness burn as brightly as it can before the darkness closes in again. The impossibility of meeting other beings is not a tragedy. It is simply a description of the universe as it appears to be. And descriptions are not judgments, they are beginnings. We describe the cosmos as we find it, and then we choose how to live within it. If we are alone, then we live as the sole heirs of cosmic awareness. If we are not alone, but can never make contact, then we live as a single island in a vast archipelago, scattered across an ocean too immense to cross. Either way, we live. Either way, we wonder. Either way, we look up at the stars and feel something. Longing, curiosity, everything that makes us human. The universe does not owe us companions. It does not owe us answers. It does not owe us anything at all. We are accidents of chemistry and time, patterns that arise from chaos and will one day dissolve back into it. But while we are here, while we can think and feel and question, we are something the universe has never been before. We are the part that knows. And knowing, even knowing that we might be alone, is better than the alternative. Better than the 13 billion years when nothing knew anything. Better than the silence that came before us and may come after. For now, there is a voice in the cosmos. It is ours.